about your amateur astronomer sideline. And we got quite lucky last night because we got a blood moon and a lunar eclipse. So we're going to talk about that too.
For sure.
Yeah.
Did you see it?
Well, I did not. I was up and I was looking out the window, but where I live in the bottom of the valley, you have the mountains there.
Oh, yeah.
And because of the mountains, by the time I had risen above the mountains, I'd missed the blood moon, and it was just a very, very bright supermoon.
Okay, so
Does that make sense?
Yeah, so you had an eclipse by the mountains, basically.
Yeah. Okay. So I couldn't see a damn thing. But luckily, our mutual friend Melody Sky Photography, she was up on the mountain last night and she saw it. She called me and said, "It's on right now. Can't you see it?" And I said, "No, I can't."
Oh, no.
I know, but that's okay.
She sent us some pictures she took from here.
Yeah, well, we'll take a look at those. Oh, there we go. Can you zoom in on that at the bottom there?
Can, but she just finished getting them on her computer, so she got them like she did not process them yet. But
yeah,
it's beautiful.
Look at that.
And yeah, on my side, I was lakeside and planning on a shoot with the moon rising behind the mountain. However, it was too misty, so we missed the start, and we could only get pictures once it had risen. So
yeah, because it was perfect last night. It was clear. You can unshare the screen now. We'll come back to them.
Oh yes, sure.
That's okay.
So here they are. Stop sharing.
Yeah, and then we'll come back to them. We'll have another look. But
then the cabin there is. Sorry, it's
okay.
A beautiful one.
And you got that picture behind you. That's a cracker.
So,
when's that from?
10 years ago, basically.
So you've been doing this for a long time?
Oh, yes. I mean, I've been doing astronomy since I'm basically 10. I've been fascinated my whole life.
Okay.
And yeah, I'm basically a huge space nerd. So
a huge space nerd. All right. Well, do you have a hero? An astronomer hero?
Well, I won't be very original here, but I'd say Michel Mayor for discovering the first exoplanets. I have a few more personal heroes as well. For example, Francesco Pepe, who designed espresso, so the most precise spectrograph we have to detect exoplanets, and who's a great person as well. That's the thing. Like, I got the chance to meet my heroes from a child, as a child, which was cool. Work with them, and when you meet your heroes and they turn out to be good people, that's very kind. That's very cool.
Oh, that's good. Just with the microphone, just keep it. Yeah, that's okay. That's fine. You're good like that. What was I going to say? Not like Galileo or anyone like that, or Copernicus, any of those guys.
Honestly, Galileo would be on my list. You know, the famous question, like, hey, if you could have a dinner with someone dead or alive, well, I'd rather have it with someone alive. That's for no reasons. But like, who would you invite at the table? And Galileo would definitely be in there.
Mm-hmm.
Like, it's amazing with how we knew a lot of people were smart, but the first one to get a telescope pointed at the sky, with all he was able to derive and understand, it's impressive.
Mm-hmm.
Like, because for us it seems logical and easy, and when we have a look at the sky, we're like, yeah, sure, it makes sense. But we have our education, we have the background, and we all learned the planets' names in school and how it worked, and to understand how it happened and to go against the whole main train of thought at the time, it's amazing, honestly. It must have been like so bright.
Yeah. What was the main train of thought at the time? That the sun the sun revolved around the Earth.
Yep.
And he disproved that.
Yeah, he disproved that because of many observations. For example, he had a look at Jupiter and saw some stars close to it. And he used to sketch whatever he was doing, because one of the main differences between messing around and doing science is taking notes.
Mm-hmm.
And
just move it. Can you move it a little bit towards you like that? Yeah, that's perfect.
Okay. And he was sketching what he was observing, and from one night to the other, he saw those 4 stars move around Jupiter, and he was like, oh, they seem like mini planets going around Jupiter. So why wouldn't all the planets do the same around the sun? And other observations he made, for example, was Venus. Venus has phases, same as the moon. And the reason it has phases is because it's orbiting between us and the sun.
Mm.
So, and he was able to understand that, oh, if Venus has phases, that means it's closer to the sun than we are. So, yeah.
So he figured it out that way.
Yep.
This is what I always get. This is always my big question when it comes to stargazing. I know nothing about it, but I like listening to podcasts and YouTube videos about archaeoastronomy. So
yes.
when you can, and now there are computer models that you type in a date and it will tell you what the night sky looked like 25,000 years ago. That's how good they are. That's how accurately they can map all these things, which is quite frankly incredible. But I was going to bring it up a bit later, but we may as well go into it right now. One of my other fascinations is like deep ancient history. I personally am of the belief nowadays that there was an advanced civilization prior to the end of the last ice age, the Younger Dryas. And all of these ancient civilizations, even like Stonehenge or the pyramids in South America, in China, well, all around the world where there are pyramids, they're all astronomically aligned.
Okay.
We are going to talk about it. Yeah, astronomically aligned to a degree of precision, which is quite staggering for what we thought were a bunch of Stone Age people who could create these amazing monuments. But the fact that they could do it. So the thing that gets me is they have in Italy, they found these deep wells on Sardinia. Have you heard about this?
Not at all.
So they have, it's like a deep well lined with stone, and at the bottom is a pool. And it's not actually that deep, but if you've got a fire on the surface, it won't be affecting the light on the water. And from what I can gather, that's how they used to, rather than stand there like that or lying on their backs, they can actually look at the pond, and that was their map of the night sky by looking at the flat pond from the reflection of the sky.
Oh, nice.
Have you ever heard that?
I never heard about it, but it's very smart.
Yeah, and the other thing that comes out of it is they can track. They were able to track the night skies. They were fascinated by our solar system, and I'm still to figure out exactly why they were so fascinated. We don't care, or you do, but the rest of the world doesn't really care
because they actually saw the sky. We
don't see the sky.
Not well. Sorry for the pun. Because of light pollution, it hides the sky. For centuries, the sky was our calendar.
Yes.
So, and people could actually really see the sky. Like, it's kind of frightening. You have 60% of the European population who cannot see the Milky Way from their house.
I know.
And a century ago, it was clearly not the same. The more time that advances, the more true nights disappears, with all the effect it has on biodiversity and humanity itself, not only for health-related reasons, but as I said, for cultural reasons as well. The sky is our cultural heritage and the one thing full humanity shares. And yeah, there's pyramids everywhere because it's the easiest way to go high. But the reason you have sky-related stuff everywhere is everyone saw the sky. And they knew, for example, when this one bright star starts to appear, then it will be time to get the grain.
Mm-hmm. The
harvest, exactly. And it's amazing that people about having an advanced civilization. You probably know about this more than I do, but I am deeply convinced that people before were not dumber than we are. They just did not have access to all the tools we have, and well, they had the main issue, they needed to survive. They needed to feed themselves. But no doubt, people were super smart, and mathematics were the same everywhere.
Yeah,
and it's insane how good it works. And even you find everywhere ropes with knots just to get right angles from trigonometry, and it's it's impressive how advanced people, how advanced stuff people were able to do with so little tools and just by working together. I think it's beautiful, and really we are quite disconnected from the sky, while astronomy is for me the most like accessible science one can have. It's you just need to go outside and have a look at the sky. For example, if you go outside tonight, like obviously the moon was the moon eclipse was yesterday, but just having a look at the moon every night, if you see it, now it will decrease up until the new moon. But just being able to compare this evolution every day is already doing astronomy.
Mm-hmm. Yeah.
And I think it's very nice.
Yeah. I'm with you on that one, 100%. I think we're going back to Copernicus. And you're talking about advanced mathematics and figuring out trigonometry before actually trigonometry, well, that we think we invented whenever it was, a couple of hundred years ago, whenever it was.
It was from the Greeks already.
Okay, so a couple of thousand years ago,
Yep.
yeah. Right, of course. And so what they would do, how they managed to track the stars in the old days, was they, from a position, watch how the star moved, and it would move a certain amount, and then they could track the angle, and that's when they, without getting into the maths of it, but basic trigonometry. And for me, is how do they measure it? How do you, in fact, if we were all, uncivilized Stone Age guys walking around in hemp clothing, how is it that you can actually get a perfectly straight edge to make a measurement? If you got a rope, if you pull the rope, it's going to be a bit longer. There has to be some method for the actual measurement. You see what I'm getting at? And it's very, very hard to do. We've got, I actually managed to break one 2 days ago, an aluminium ruler with a perfectly straight edge. And it's been perfectly marked out, accurately marked out with centimeters and inches. And because of that, I can measure things accurately.
Yeah.
But apparently, in those days, they didn't have any rulers. I mean, none of it, for me, none of this makes any sense. Is that they must have had some reason or method to do accurate measurement. Otherwise, they couldn't do the mathematics.
Yeah, but they actually had like common measurements, and also something like for example for angles, if you get your arm straight ahead and raise your finger from one end to the thumb to the other, it looks like 2 degrees. If you raise your hand, that's basically 10
Right.
degrees, and if you make the telephone sign, like this is roughly 25. But also for angles, like a meter is basically the distance from your hand to the other shoulder. Because if you take the length of rope, straighten the rope like this, then you'll have basically a meter.
Mm-hmm. But it's not exact measurement, though. It's not precise measurement.
No, but there's no need to all agree on the same measurement. They might, I don't know how they did it. They might have a reference where they were working. And for example, the ropes with the different knots might have been like sort of standardized. They had standard weights, for example.
Mm-hmm.
So I'm quite sure they had to have standard measurement tools.
Mm-hmm.
And they use different units. For example, the Greeks used stadiums as the unit of length. And yeah,
on the pyramids, they found 3 different standard measurements.
Okay.
Guess there was the foot.
Okay, the foot.
I think it's called the imperial foot, and they had a meter. And apparently, well, as we've been led to believe by history, that the meter was invented by a French guy back in the 18th century. And again, this is where it all starts to get a bit weird for me. But I don't want to get sidetracked into that kind of.
But I mean, it makes sense because those are all human proportions. So, and humans have been roughly the same size for ages. So it makes sense that we can use our body as a unit, because that's the one thing we always have with us. Like the telescope was invented like in 1580-ish. The first one to use it, turn into the sky, was Galileo in 1609. Sorry. But astronomy didn't start through the telescope. We already knew a lot before because we all have two telescopes with us, our eyes. So I think it's sort of logical that our units of measurements come from our body because that's what we have everywhere.
Yeah. Well, that's what do you call it in French?
An inch.
Yeah.
Un pouce.
And pouce is a thumb in French, by the way.
Yep.
And that's what they call an inch. And that's what we use for measuring inches. You put your thumb down, right?
That's why it's roughly 2 degrees, because 2 degrees at 1 meter, 2 centimeters at 1 meter is basically 2 degrees.
Mm.
That's why we say, like, straighten up your arm, lift your thumb, and from one side to the other, it's 2 degrees. If you play Fallout, you know how to do it.
Yeah. Yeah. Okay. Yeah, I wasn't expecting to go into that. But how was Galileo actually able to, what kind of calculations was he making to prove it? Was it mathematically proven, or how was it done? Or was it just by the observations?
I think it was just by the observations from Galileo. I honestly don't know.
Yeah. And what happened to him?
Well, he got a visit from cool dudes called the Inquisition. And, well, he had to renounce all his findings and was assigned residence, which was basically the end of his scientific career at the end. So, but hey, he did not have the same fate as friend Giordano Bruno, who was one of the first ones to theorize. One of the first ones, no, but one of the first modern thinkers to theorize the existence of exoplanets, of worlds around other stars than the sun. And he got a visit from the same people that he burned at the stake.
Yeah, they burnt him.
Yep.
What about what was the other one? Who was the other one I mentioned?
Copernicus.
Copernicus. Yeah. What happened to him?
I honestly
don't know
for sure,
because if you look at I saw it in one of these tablets from ancient Sumer, or ancient Mesopotamia. I forget which actual civilization it was, but let's call it Sumer. And they've got these clay tablets which are very famous, and they have on them representations of the sun and the planets around them, including the rings of Saturn. And one of the planets has quite clearly what looks like a ring around it. Have you seen this?
I haven't.
Ah, right. I have to find that. And pull it up for you, because that's a really interesting one. Because
it is.
How do they know?
That's an excellent question.
It is a good question. And the same with it's the temple of Dendara. It's Dendara is the temple in Egypt, and they have on the ceiling, it's a representation of the sky with all the planets and everything on there as well. So they clearly knew something was going on. They must have had the ability to see, whether they had telescopes or whether they figured that stuff out. I just don't know. But it's just so fascinating when you hear that sort of things. And we're told that, you mentioned that before the Ice Age, it's just the same. We're the same humans as we are now. In fact, probably at least 300,000 years, if not more, according to later study, it goes back to even possibly even 900,000 years, that we're exactly the same, with the same brains. And we've had the same periods of stable climate, despite what everyone says now. We're still in a very, very stable climate compared to...
It's starting to become a huge mess, honestly. Like, if you look at the temperature increase, it increased more in the last 2 decades than since the last ice age. And the time scale of these changes, was staggering.
Yeah.
It's
funny enough,
up an alarming rate.
Well, funnily enough, we were up on the glaciers. We were up in the top of the mountains on Saturday with our friend Melody. And they have at the top of the highest mountain, so it's about 3,300 meters. It's the Panossier Glacier over there, the big one over there. And it showed you an artist representation of, today you can see it. That's an original photograph. They had one from the 30s, I think it was. And then they had projections of what it was like during the mini ice age between whatever it was, middle of this last millennia. when it was very cold, and it was big. It was coming almost right down the valley. It was huge.
Wow.
But then it showed you what it was like 1,000 years ago, and it was tiny. It was actually a lot smaller than it is today. So 1,000 years ago, it was much warmer than it was. I mean, it must have been something that was going on that the glaciers were so small. And that just is, anyway.
No, yeah, but the main thing is really the time scale of these changes and their origin. So that's the main thing is the climate change happening right now. We know it's man-made. I mean, a consequence of our greenhouse gas emissions, which is also the size of the curve is going up exponentially, while before it was like a longer and what's the opposite word for steep? Shallow-ish curve?
Yeah, shallow curve.
Shallow curve. Well, now it's like we're starting to see mountains just go down because of ice melting, and it's well, interesting times too.
Yeah. Gee, but it's just I didn't expect to see that. But I do know that when the glaciers go back, they find forests underneath, which is, I guess, counter what we're currently taught. Because there must have been what would have happened 1,000 years ago that made all the glaciers melt? Who knows?
Honestly, I don't know.
Yeah, interesting. I don't want to sidetrack there. Little sidetrack.
Don't worry, I keep getting sidetracked all the time as well. Because that's the thing is there's so many interesting subjects.
Yeah. Well, I was gonna. So you mentioned it before, and I sent you a message on Saturday. So this is Monday. The 8th? So yesterday, the 7th of September was the blood moon, as they call it, the lunar eclipse, which I missed. Now I've got the pictures. I'm going to show them again in a sec. So I mentioned the fact that when I was a kid, I remember very clearly being able to see the stars. And I'm not that old, I'm 52, and it's not, that's not that long ago. In fact, you could see them 30 years ago, 20 years ago, you can still see them. But we have these very powerful lights in the towns now, these LED lights, which has made everything, well, so it almost turned the night into day. And so we can't see the stars. And I think I sent you a hashtag, I think we'll use for our new campaign, which is Reclaim Our Stars. Because I think, personally speaking, I think it's a good idea, a great idea for us. I mean, all they're going to do is dim the lights or put motion sensors on the lights so they go off and then they come on if you're walking past, or that kind of thing. But you mentioned when we had a chat on the phone a little while ago, you live in a place called the Roll, which is down on Lake Geneva, which is very close to Geneva, as that happens. You came up from there today, and that is. Tell us about what you were talking with the local council about.
So something that is quite cool is the local council has started turning off some lights, like lakeside, starting at 11, which for me was a very good surprise because I left Hull for a few years to go and live in Portugal for my PhD, then came back and they implemented this change. And for the first time, I was really able to see the Milky Way from the city I grew up in. So it was like, cool. So I decided to go and take a picture of, there's an island there 100 meters from the lakeside. If you can swim there, it's actually a very cool place. And I managed to get a picture of the Milky Way with the island in front. And I sent it to the whole Facebook group, like, hey, I just wanted to thank the city council for turning the lights off because it made this possible while I never think it would have been possible. And got contacted, and we are talking to reduce light pollution in Harvard and to also educate the public about it, which is very cool, I think, from their side as well. Like,
yeah, I love that.
Yeah,
I love it. And here, especially because you actually can see the stars because we live pretty remote from any major cities or anything like that. There's no real light pollution. If you go on the mountain, you can really, especially up where we were the other day, there's very little light pollution.
Oh yes, your main source of light pollution around here is southwest. You'll have Torino, and on the south you'll have Chamonix.
Yeah, and you got Sion, the city down there, which is not that. I mean, it's a city, but it's not. It's not a big city.
Yeah.
It's a couple of 100,000
also
people.
You have actually the whole lake sides, Geneva, Lausanne,
That's
Montreux,
all lit up.
everything. Like it also lights up the sky like quite a lot.
Yeah.
But there are about light pollution. There are mostly 5 pillars for light pollution. The first one is lights need to be useful. Like as I said, having motion sensors, only use light where it's needed. Like you have a lot of empty parking lots that are just lit up the whole night. What's the whole point? Also, the lighting should be targeted, which that means light should be direct. Just get the lights down. When you go up the mountain, you have less light pollution. That's beautiful. But you still see some lamps as point sources. That means this light is going directly towards you. So it never went to the ground. That's just wasted energy.
Yeah.
It also needs to be as low level as possible, because the thing is, our eyes get adapted to obscurity by 2 ways. The first one is instantaneous. Your pupil dilates, the eyes get bigger to get more light in. But the second one takes between 20 and 45 minutes as your eye becomes more sensitive, because it creates a liquid called rhodopsin. And that's what happens when you wake up at night in your room. You see everything around it. You go up, you walk up to the fridge, you open the fridge door, and then you cannot see anything.
You get blinded.
Yep, because this molecule is extremely sensitive to light. So next time this happens, hide an eye, and then you'll have an eye to come back. But it also means you need a lower level of lighting to be able to see the same thing.
Yeah.
If you use light that is too bright, your eyes will never get adapted and you'll blind yourself. Also, the fourth pillar is the light can be controlled. For example, let's be fair, there's no lights needed, as if from midnight to 6 in the morning. There's barely anyone out there, and people who are out can barely see their hands anyway.
Yeah.
And also, the lighting should be warm colored, because the blue and UV lights are the worst for biodiversity and for humans as well. So if you can at least filter out the worst wavelengths, the worst colors, it will minimize the impacts on our ecosystem, because we really need to understand we are part of the ecosystem. It's not something like, oh, there's the humans and then nature next to it. We're living in the same environment, so we have to share the place with everyone.
Exactly. That's one of my things at the minute, is I'm getting the blue light free light bulbs in the house.
Yeah. And I'm quite sure you sleep better.
Oh, well, I haven't got them yet. I'm hopefully going to get them next weekend after. And I wear the blue light blockers when I'm in the evenings with my laptop, certainly with the TV. I've got the red ones like the gamers wear. Makes everything look a bit orange, but you know what? The big difference it made actually for me was being able to fall asleep a lot quicker, because I'm trying to bring my circadian rhythm back into sync, basically. And if you've got birds and all the other wildlife who are around these car parks, they're getting blasted by this very strong UV light. And I live it's not next to me, but it's close enough that I'm in my bedroom in the street lamp outside, and I've got a thick wool curtain and it still comes through. It drives me nuts. And I just don't understand why it's being done. But it's great that you've done this with Roll. And I think we're going to start a petition. We talked about it the other day. We're going to start a petition, get the kids to stand outside the supermarket down there with a petition saying, can we turn the bloody lights off? Or at least turn them down and where we live? Because it's just, as you say, there's no need. And every shop, every bank here, where we are right now, at night, they all leave the lights on, full beam. As in, the office lights are on and the signs are all lit up at night, and there's absolutely no reason for that.
There is no need, and
it's a waste of energy, really, isn't it?
Energy, and turns out from experience, the argument you can give people to make them react is, hey, do you see the lights? That's your taxes.
Yeah.
And yeah. And
yeah, that's a good point. And your electricity bill.
Yep. And just going back for eclipses, the next one you'll be able to see will be on the 3rd of March. If you are on the east coast of Australia, west coast of the US, or in Japan. And the next one you'll be able to see from Europe is a partial one, but a very, very deep partial one. It's 96%, and it's on the 28th of August, 2026. So you'll only have partiality, the partial path in Europe, but it's going to be pretty cool. I'll send you the links if you want to show it to people afterwards. And also, August 2026 will be awesome for eclipses because you'll have on the 12th the next solar eclipse visible from European soil. So you can see it from Spain and Iceland.
But not here.
Not here. Here it will be at 98, 99%. But if you have a solar eclipse at 99%, you're missing 99% of the show.
It's a bugger.
Hey, it's okay. It's 10 hours of travels for a lifetime memory.
I have seen an eclipse.
Nice.
Not a
annular one?
Hmm?
Annular one, or
not the moon, or sorry, the sun wasn't blocked out perfectly, but it was, it was a tiny little sliver on the side.
Nice.
But I was a kid. I saw that. But last night, for instance, here, because the sky was super clear, as you can tell by Melody's photograph there, it was so bright last night. Is that because partially because of the atmospheric conditions. And there was no wind, there was nothing, and it had been super still all day. And normally in the mountains here, it does blow, it gets windy in the afternoons because of the heat and changes in the valleys and everything's steep and cold air rushing down and whatever. I don't know how it works, but it was super clear. And I don't know if it was super bright because it's the perigee, it's the closest that the moon comes to the Earth.
Yes.
It was yesterday.
Yes, but it's basically a 5% increase in brightness. So it's less than just having a less humid night as yesterday night, if I may say.
Yeah.
Works. And
so
the
bright.
full moon is very, very bright, actually.
Yeah.
Like,
I could read a book outside. I tested it.
Like when there's the moon, there is no need for street lamps.
Exactly. And how cool would that be? I mean, this is like my kids, they've seen the Milky Way, but we were up in a mountain camping and I had to show them. I said, that's the Milky Way. But I remember I was very young. I was probably 7 or 8. I went to South Africa.
Oh, yes.
And we were out somewhere in the bush where there's no light, and this was nearly 50 years ago, which in my terms was a blink of an eye. It wasn't long ago, it's not long ago. And I remember we were driving back to the city and it was, the Milky Way because in Scotland where I grew up, you do get clear nights, but it's often cloud. But you could still see the Milky Way, but it was just alive. This thing.
You understand you're inside a galaxy because
in
the southern hemisphere, even more so, because the core of the Milky Way gets higher and you have it above you and you see the arch of the Milky Way and you're like, oh, wow. Something people often tell me, like, oh, it looks like we're on a terrace above the universe. Like, it's not like this. That's exactly what's happening. You're seeing the sky with your naked eye and just being outside and truly seeing the sky in the dark. I find it very relaxing. Some people panic, but it really shows us how insignificant we are.
It's amazing.
It is.
It is absolutely incredible. And it's, I've no wonder that people were in the old days, as we were talking about before, were so fascinated by the night sky because they're trying to figure out what it is, right? And they figured out that it's basically a giant sky clock and that they could predict things. And who knows if they could predict cataclysms and meteors. And because you can tell us about it, but we pass through several meteor showers per year. There's the Perseid and there's the Taurid.
Yeah, or the Geminids. And
there's quite a few.
Which are actually the most prolific ones. Around the 14th of December is the time of the year where you'll have more shooting stars and the nights are longer. The reason everyone knows the Perseid is, would you rather spend a night outside in August or in December?
Mm-hmm. That's a good point. But, if it's 7 o'clock at night and it's pitch black, and you can still see all the stars and the shooting stars.
But it's very cool that you took your children out to actually see the Milky Way because a lot never did. And that's something I love doing, just sharing the sky with people because it's ours. It's everyone's. So just something we ought to know because it's there half the time.
And you can't help but get philosophical. If you I don't know. I've never done it, but if you smoked a joint and went with your pals and just laid back and looked at the stars, or took some mushrooms or something, who knows? But you don't even have to when you're doing that, because you look up and you can see the constellations that you know, but you've probably forgotten the name of the whatever they're called, but the famous ones, and then being able to see the pole star. And I used to be in the military, so I'm very good at the close, which actually your shooting eye.
Yep.
Keep that one closed, and we did everything at night because that's how you stay hidden, right? So we did everything at night to the point that if you had a torch, you couldn't use it because it's just a beacon, right? You can get seen from miles away. And we'd put red cellophane, so red clear plastic over the top, or even we'd get black tape on the top and make a pinprick, so just a tiny bit of light would come out, and you hold it up to the map so you can do your check navigation at night when there's a moonless night, and you can't see the hand in front of your face. And then on the moonlit nights, we had to use the land, the terrain, as if the sun was up, because you can get seen from miles away.
Yeah, no, but that's a lot of excellent points you made just here. Like, for example, about the red cellophane and just the pinpoints. That's the reason we use red light at night is historical, and for me, it's a nonsense. It just when we were doing analog photography, even before when it was like glass plates, those plates were very bad at picking up red lights. So you could still have some light to see what you were doing without burning your pictures.
Mm-hmm.
But the thing is, our eyes are very, 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 very bad in low lights, and they're good in low light, but they're very bad at picking up the red color. So for the same visibility, you'll need a lot more red lights to see than just having a white light source, but as dim as one can, because then you'll have the same visibility and hurt your night vision less. And as you said, light is just a beacon. When you're at night and you get your torch out, you'll just blind yourself and the others around you and make yourself visible kilometers away. That's literally the reason when you're at night in the mountain and you have an emergency, people tell you use a flashlight to do an SOS because you can see it from across a valley.
Oh, easily.
And you're just telling people, hey, that's where I am, and you won't be able to see them. And that's the same principle applies for when you talk about public lighting. People are saying, oh yeah, but what about security? But you have less crime when you have less lights, and it evens out the field. Because, I mean, you've been in the military, so you know how it is. But when you have a path that is lit up, and people are walking these paths, not only you see them coming from hundreds of meters away, but they are also blinded by the lights, and you can be like 5 meters from them in the darkness, and they won't be able to see you.
Yeah.
And I actually had a very interesting chat, like at 2 a.m. with a random girl in the hall, and she was very kind, and quite brave, because as a white guy approaching her at 2 a.m, like, hey, do you have 5 minutes to talk about light pollution? I'm kind of glad I didn't get pepper sprayed. And she was very open about it, and we talked, and I was like, what's your opinion about this? Because we're trying to have a project with a municipality, but I won't propose a project that would not fit what the public wants. So what's your opinion? And she told me, oh yeah, it's too bright, because she actually told me she felt unsafe because of how bright it is, because she could not see what was next to the path.
Yeah, in the dark.
And that's the reason people are frightened of dark alleys. It's not because the alley itself is dark. It's because the one street next to it is bright.
And another thing, I suppose, is in the dark, it's much harder to make out if the person's the size of the person and if they're male or female.
Yeah.
So that you're not going to be able to see that. That's a good point. We were in Costa Rica a couple of years ago, and we went to this place called Nasara, which is, they have no streetlights.
Wow.
On the main strip. So you got and it's a dirt road. and I think they quite like it. I loved it. So you're walking. We went for some food, and we were going to go for a couple of drinks. We'd been surfing all day, and you're walking. It's pitch black. They got the hotel lights, and the bars are lit up, but not super bright. It's actually relatively. But then again, your eyes are so accustomed to the dark because there's no street lights that you don't need it to be super bright. And it was so cool. And we were
Better for everyone
yeah.
and more relaxing.
Yeah, and they do. There is lots of studies that show that the blue light causes a lot of stress in your body, and it's got terrible, terrible effects on your sleep. And I mean, I've gone
Also on your health, like it's been related with dementia and Alzheimer's as well.
well. It's because your circadian rhythm gets so buggered up, and it's such an important thing. So
Yeah,
in the
when you're
military,
into astronomy, it gets so messed up. Like my circadian rhythm is
because you're up at night.
Oh yes,
of course. But what was I going to say about the health benefits? Is I don't. In fact, I usually get up first in the morning, and if I'm preparing breakfast, I light candles, keep it nice and dark, and the kids love it. We have breakfast by candlelight and dinner in winter. Sorry, not dinner.
That's so cool.
Yeah,
that's so cool.
They love it. It's like a camping adventure.
Yeah, and it also like lets you wake up naturally instead of like, hello, here's a floodlight in your face.
Yeah,
nice.
And that's another thing people do, and probably the most guilty item about it is a smartphone.
Oh yes.
If you wake up in the middle of the night and you pick up your phone, so you're getting blasted by the blue light. Your circadian rhythm is totally messed up because it thinks, oh, it's morning, I'm awake now, and of course you're not. And then that is another one of these things. Or even sitting in your bed at night with the lights off, looking at your phone, unless you have these blue light blockers, which even then is still probably not the best thing to do. But that it all works, and it affects your health in such a detrimental way that people, I think, we're just beginning to realize how bad it is. And the studies I've been looking at, reading. I mean, I'm clearly not a scientist, but you can still read and take in information, and it is not good. And anyway, so I'm going to try and get my house completely blue light for the light bulbs in the house to be blue light free, and see how that affects.
I'm interested in seeing results.
There
I
are
actually it the other way around. Like I struggle with mornings because mornings are just too early, and
you're still young.
Yeah, but I'm a night person.
Right.
Like I'll quote Terry Pratchett on this one, but I really think no one deserves to see 7 o'clock twice in the same day.
Oh, I'm usually up at 6, sometimes 5, but I go to bed early.
Okay, yeah, I go to bed early as well, but in the morning. So, and when I struggle to wake up, I actually just get my phone out and scroll aimlessly for a bit, and I'm like, oh yeah, no way I'm going to sleep again.
Yeah,
and
people
it's
do
the
it.
same at 2 a.m. So
I have to turn mine off because then it's too much of a hassle to turn it on if it's next to my bed. Otherwise, I'll leave it upstairs. I can do that also as well. Different room. Yeah. Yeah, interesting. So, astrophysicist. How did you get into? What was the draw for astrophysics? Sounds like a very difficult subject at school.
Not necessarily. I mean, I've always loved it, and well, growing up in Switzerland, that's the team that discovered the first exoplanets, the first planet around another star than the sun, was a team from the Geneva Observatory. And I always loved looking at the star, and there's this fascination when you're looking at another star, like, oh, is there a planet around or not? And the only way to find out was to become an astrophysicist. And also there's this thing where if you like driving, I'm quite sure you'd like to try a Formula One once. And when you're into astronomy, like, oh, I want to use the biggest telescopes as well. And that was the path to do it.
Mm-hmm.
And yeah, it's very different from amateur astronomy, actually. Like most professional astronomers don't know how to use a telescope. Because it's not needed. To be a good astrophysicist, you need to be a good physicist. All the data comes from telescopes. Everything's digital because we were more precise than with our eyes. I wish we could find an eyepiece on the biggest telescopes, but it won't happen. But right. very cool. And then I had this opportunity to go I did a bachelor's in physics, then a master's in astrophysics, and now I'm doing my PhD in this. And it actually came quite naturally because you have to do something in school. I loved physics. I loved astronomy, and I knew from a very young age that's what I wanted to do. I was like, I want to discover new planets, and I want to be able to characterize them. And thankfully, I got the chance to be able to do so. Yeah.
But just explain, an exoplanet, that's a planet like the moon is to the Earth.
It's just a planet. It can be, for example, the first one that was found 30 years ago, 51 Pegasi b, is an object, 44% the mass of Jupiter, going around its star in just 4.2 days.
Right.
It's just planets that are outside the solar system. We almost know 6,000 of them. We're at 5,989. So we'll get the 6,000 marks in the following month or so. 30 years after the first one that was discovered. It's awesome.
So they're outside our solar system or outside our galaxy?
Our solar system. For now, we still haven't detected planets in other galaxies just because they are too far and the stars are too dim. Because we have two main methods to detect them. So historically, the first one is what we call the radial velocity methods. It's based on the Doppler effect. The you'll get, speaking a formal one. So when an ambulance or a car or whatever comes towards you, the sound is compressed. The sound wave is compressed. So the pitch is higher. And when it goes away, the pitch is lower. The same happens with the lights. When something is coming towards you, you see it as blue. And it's going away, you see it as red. It's a tiny effect. But the thing is, when you say a planet is going around the star, that's a lie. I mean, it's a kind lie. It's a simplification. But the thing is, both objects orbit around their center of mass because the planet also attracts the star.
Mm-hmm.
The problem is you cannot see the planet because it's too close to the star, too dim. It would be like trying to take a picture of a firefly going around a lighthouse. So the only thing you see is the star doing this motion. The thing is, the star is so far away that you only see a point.
Mm-hmm.
You cannot see the motion most of the time. So you can analyze its color. You use what we call a spectrograph, basically a prism, and you see the spectral line. So when you take all the color of the star and to get the rainbow, you have some dark line. And every line corresponds to an element inside the star, so you can know its chemical composition. But if you take a picture of a star today, then tomorrow, and so on, sometimes you'll see these lines shift towards the blue and then towards the red, blue and red. So you see that the star is going towards you and away from you. And from how quick it's going, you know how massive the planet is. So with this method, you can know the mass of a planet you cannot see. Which I think it's pretty cool. Just for reference, the Earth makes the sun move at 9 centimeters per second. It's quite slow on a year, but it's still something, right? And the other method, which has become the main method for detecting exoplanets, is if you're lucky and the planet's orbit is aligned with us, it can cross in front of its planet, of its star. That's what we call a transit. And then you monitor the brightness of these stars. And when the planet goes in front of it, you'll have a dip. The bigger the planet, the deeper the dip. And this gives you the size of the planet. And when you combine both methods, you know its size and its weight. So you can infer its density. So now we are able to, on planets you cannot see from the Earth, we are able to tell you whether they're rocky or gaseous. And I think it's awesome.
Well, Jose, I'm glad there's people like you out there because, I mean, you've explained it very well and very simply for me. I'm sure it's a lot more complicated than that, but
it's not. That's the thing. The physics are very simple. And then the problem is just to get this 9 centimeter per second precision. For now, with our best instruments, we are reaching 10 centimeter per second barrier. The problem is you need instrument to be super stable because what you're detecting is a shift of the spectra on your sensor.
Mm-hmm.
But if the air pressure changes, the refraction index of the air changes, so the light will shift. So the instrument is in a vacuum vessel in a room stabilized in pressure and temperature. In another room, temperature and pressure stabilized to make sure you have as little drift as possible. And you need a calibration line, just a reference. You were talking about an aluminum roller before. It would be like you put a roller next to your spectra just to know exactly where the lines are. And to get this 10 centimeter precision, you need this calibration lamp to move less than a picometer during a night.
A picometer.
It's insane. And the main problem we have is all is well if the stars are stable, but they are not. Stars have eruptions, spots, granulation, and all of this is making a noise. I mean, it's making a signal. We call it a noise because it's not what we want to detect. It's like you want to detect your planets. You want to hear a needle drop, but you're under a tent and it's raining. You first have to account for the noise of the rain to then be able to hear your needle. By the way, good luck with the post-processing of the podcast with the construction outside.
That's fine.
It's basically the same thing.
Yeah.
And the sun in a year, normal activity gives a signal of 44 centimeters per second, 5 times more than the Earth. So that's what makes detecting a second Earth extremely complicated.
Mm-hmm.
But it's interesting. It's physics. It's and data analysis. And every day we're going closer. And I really think like we should not be afraid of what we don't know because that's where the interesting part is. We don't know. Cool. We're yet to discover it.
What do you reckon? Is there a chance of finding a planet like Earth somewhere out there?
Yeah. But the thing is, finding life is a whole other subject because if we take the problem the other way around, we're quite sure there's life on Earth. I mean,
we're here.
Yeah. But if we were to duplicate the Earth and put it around the closest star to the Sun, Proxima Centauri, around which we know at least 2 planets, which is cool, and we were to look back at the solar system, we would not be able to detect the Earth.
Really?
Yeah. And another way, I mean, with optical telescopes and whatever, with these main techniques. Another way from the SETI program is looking for radio emissions. But same, let's take it the other way around. There has been life on Earth for 4 billion years. We've been emitting radio waves for the last century and a half.
Yeah.
So we need to be at a good distance and at the same time. Because we said they might have been advanced civilization before the Ice Age. But for how long?
Mm-hmm.
Same. We are in a more or less advanced civilization. But same question goes, for how long?
Yeah. I've been following a guy. He does research, and he's claiming, and I know nothing about it, but he's claiming that there is a second sun, the Earth, because this is what he says. Now, you can obviously correct this because I haven't actually watched the YouTube video yet, or not his YouTube video, but his video that he made. And he's the guy that he was videoing the moon. It's like a Nikon, no, not a Nikon, Fuji P1000 on the moon, which is like 1,000 times magnification, so you can get a really good picture of the moon. And there's like this shift, this line. Have you seen it? It's almost like a page refresh, on the old internet, and which got millions and millions of views because you can't really. He did it. He made loads of videos of it happening. And it is like a page refresh. It's what it looks like. This wave just goes across it. Now I don't know what it is, and I'm not sure he knows what it is. But it was very interesting that he caught that, and he's been doing the same thing, but instead of videoing the moon all the time, he's doing the sun with all these crazy filters and stuff, so he doesn't burn his house down, I guess. But and one of the claims is that I think, is it all other galaxies or whatever, solar systems, they have it's a twin star.
Some of them are, but not most of them.
Okay, so some of them have twin stars.
Yeah.
Okay, and then there's one, and I think they call it Nibiru. Is that what do you know anything about this? It's not. I don't think it's a conspiracy theory because it's been talked about, and we know that but there's been talk about the black sun, the second sun.
It's more or less it is, honestly.
Is it just bullshit?
More, yeah.
Okay.
Unfortunately, yeah. As much as it would be fun, there's no evidence for a second star in our solar system. There might be evidence for 9th planet far away, Planet 9, which you call, but which we are yet to discover.
Oh, maybe maybe I'm getting confused. No, I am getting confused because well, it used to be the 10th planet, but now Pluto is not a planet anymore. Poor Pluto. But there is meant to be a 10th. Maybe that's Nibiru. I'm getting confused. You probably know better. Well, you will know better than
I don't know if people call it Nibiru because there has been this name floating around for ages, like for Nibiru, for an exoplanet in the solar system. Some people would say, oh yeah, it's right, it's opposite the Earth and always behind the sun. That's why we never see it. So, oh, it's inside Mercury's orbit, or oh, it's far away. I think the consensus for the 9th planet is Planet 9 for now, until the person who will discover it will get to name it. So.
Jose Rodrigues.
Oh no, probably not. I'm looking for planets around other stars, not in the solar system. And there are a lot of teams doing it, and it's gonna be extremely complicated. It's easier to find planets around other stars than this eventual 9th planet in the solar system. The reason being, we're looking at the light from the stars, which is quite bright. The problem with this planet is it will be very far away, so very dim, getting quite little light from the sun. And also the way we detect planets in our solar system is you basically take a picture of the sky, take the same picture some days, months, years later, and you look for objects that moved. So first of all, you need to be able to have a picture deep enough to detect these planets. But you'll need a second one to detect it and see it move. So there are quite a few teams already looking for archival data, archival pictures to try to find it, with no success for now. Because like the first planet that was discovered through calculations was Neptune. And Urbain Le Verrier gave the position like precisely to 1 degree, which is nice.
And who was that? Did that?
Urbain Le Verrier, a French astronomer. Okay. And he sent a letter to the director of Berlin Observatory to say, hey, have a look at this region of the sky. And he confirmed it basically the same night.
Wow.
Yeah, it's amazing. And people were trying to use the same method to write like, oh yeah, if there's another big object, it might be there. And it's very close to the Milky Way. So there's a lot of stars. So it's even harder to detect the very faint one in the field because it's super crowded. It would be like, I don't know, you have a crowd of people and you're trying to find a mosquito at the walking pace. So it might be there. Detecting it is harder, but there are people way more competent than me on the subject. So let's give them time.
Yeah.
And
okay, that makes sense. The other thing I was going to ask, I've watched a lot of videos about getting to and from the moon, and one of the big things that you hear amongst the people who are skeptical of getting humans to the moon and back safely is the Van Allen radiation belt. And can you describe what that is, and is it possible for humans to get through, or what?
In a nutshell, it's the Earth is a huge magnet, and this magnetic field just shields us from solar rays. For example, the parts that are where this field is weaker-ish, or where it doesn't act as much as a shield, is near the poles. That's why you have northern lights or southern lights.
Yeah.
And so basically, once you go out of it, you receive more radiation from the sun. Doesn't mean it will kill you because the spacecraft is shielded. Just means the odds of getting cancer are getting higher and higher. So that's basically it. So
but you can get through it.
You can. If you are in a spaceship, you couldn't like on your own. But if you're outside on your own in space, solar radiation is not what will kill you.
It's not that will kill you.
You'll die from exposure first.
Oh no, I know. I
know. Sorry.
No, I know
yeah.
that.
I mean, we take them into account. Spacecraft engineers take this into account. Like when building spacecrafts, they try to shield humans from it, and it's always like an acceptable risk or not. One of the main reasons we haven't been to the moon again is it costs a lot of money, and nowadays we won't be able to do this at such the human risk that was taken before. Like for Apollo 11, and the president had a speech ready. Should they not make it? Because the odds were very real that they would not make it. Like nowadays, astronauts are selected for being doctors, scientists, usually both at the same time. For the Apollo program, they were test pilots because they needed them to be test pilots.
The crazy people.
It's extremely brave, yeah.
Yeah.
But
yeah, that makes
honestly,
sense.
If you had a set of skills, wouldn't you do it?
I mean, it'd be worth a shot, but not on that flimsy thing they did in 1960, whenever it was, 1969 or whatever it was. That I went to the Natural History Museum in London.
Oh yes, they have an Apollo capsule there.
I mean, come on.
Yeah.
There's no way.
3 people inside.
Yeah, there's no way that thing. It looked like made out of aluminium foil and cardboard.
Yeah, and just the intrusive thoughts you'd get. That's why I wouldn't be an astronaut. But like with your pen, they'd be able to stab through the lunar model with a pen.
Yeah, it looks so flimsy.
Yeah.
It looks like something, a science project a kid would do.
But that's basically this. That's basically
I wonder if they had something different. And this is the nonsense they're showing us, because it's just, but what about like a micro particle of dust going at 77,000 miles an hour? Like just flying and goes straight through that thing. Wouldn't that just destroy everything? Is there not lots of space dust out there?
There is space dust. Like, for example, the space station is getting hit every day.
Yeah, and then you can hear it, apparently. I've seen something, and they're talking, and there's like, blink. Oh, that was a big one.
Yeah.
And, just takes one of those. That's going to go through an astronaut.
Yeah, like that's the risk they were willing to take.
Okay.
Right. And that's why, like, it would have been so hard to fake it. Like, just imagine the technology from 1969. Our old TI-30 calculator had more computing power than the lunar model. Like, they needed to do some math themselves. Like, and honestly, the thing is, it would have been more expensive to fake the moon landings than to actually go there and do it.
I don't know.
That's the whole thing. And they brought back like kilograms and kilograms of samples.
Yeah.
And for me, I think the best proof you can have that the Americans went to the moon is that the Soviets confirmed it.
Yeah. I did see that. Yeah. It's just
because even nowadays in an observatories can shine a laser to the moon and reflect them on mirrors left there by the Apollo missions to actually measure the moon drift. The fact that we know that the moon is drifting away at a few millimeters per year is because we're measuring its position with extreme precision by shooting lasers on the moon and reflecting them on mirrors left there by Apollo missions.
Yeah, I'm not saying.
I'm not
saying at all, and I'm going to make this perfect
clear.
That they didn't go to the moon.
There might be people listening that might.
No, I know. Yeah. Well, they probably mentioned the fact. In fact, I've done a podcast about that. And so I'm saying I'm not saying they didn't go to the moon, but in that little flimsy thing, that lunar lander. Anyway,
no, it's impressively brave. Yeah. I mean, the difference between bravery and stupidity is the outcome. That's what makes life so complicated.
Yeah, like that guy that went down in the submarine to the Titanic with his kid and his friends. You know, the one that
that imploded.
The thing that was an absolute death trap.
Yeah, but I mean,
yeah. Anyway, what I was going to ask about next was we hear about space being empty, and the physicists, the scientists who know this stuff say they call it dark matter. Is that correct? Okay.
There is a lot of matter. We can measure its existence, but we don't know what it is.
Yeah. So what's the current best thought of actually what the dark matter is?
If I were able to answer this question, I'd go to Stockholm, get a Nobel Prize, and come and answer.
So, so nobody knows.
Some people might know better, but we have no clue. The only thing we know is it has some mass.
Mhm.
Because the way we detect it is there's this concept called a gravitational lens. So when something massive distorts space-time, and when you have like a galaxy cluster in the background, your massive thing here, it will move the light. And if by chance you're here, you're at the focal point. So congratulations, you have a huge telescope there.
Mhm.
And how much it distorts depends on its mass. And from the mass we can observe and the distortion we have, we know there's a lot of mass missing. And we can see it, so we call it dark matter.
Mhm. We just don't know what it is.
We don't know what it is.
Yeah, because
It
in
might
the
be
old
very massive and low interacting particles. We don't know yet.
yeah, because the not philosophers. What are they called? I've got a friend who's one alchemists, and for the ancient from several hundred years ago, there was four elements. Well, five. They used to say the fifth element was ether, which was well, that's what they called it, and it was that. And I think I can't remember because I don't know. I mean, you obviously you know what you're talking about, and I'm just a guy who watches too many videos on YouTube and listens to too many conspiracy podcasts. But at the same time, when we get told that it's out there, we just don't know what it is, and you think, wow. I mean, it's just a giant mystery, and that's it, and nobody knows. There's no even thought. Is it electric? Is it conductive? And we don't know.
I mean, people in cosmology might know it better than I do because it's not exactly my field of competence. But like, they are, for example, what you call WIMPs, as I told you, like weakly interacting massive particles as an hypothesis. You have some hypothesis of what it might be, but we're yet to measure them to find it.
Mm-hmm.
So we only know that from our understanding of the universe, there's massive stuff we can see.
Mm-hmm.
And it makes a lot of our universe, like 20-ish%.
Yeah. So I have a friend who's a physicist also, and he's at CERN, which that Large Hadron Collider probably goes underneath your house in Roll.
Yep. And not yet, quite, but like the other way around. But honestly, you might be able to answer this question better than I do from the particle side of it.
And he is, I mean, you're a very, very intelligent guy. He is just a also a very intelligent guy. And I like to like wind him up a little bit when I ask him questions. So I'm going to ask you this one as well. Why is the theory of gravity still a theory?
Because there is this huge misconception on the words we use in science and commonly. Theory in science is something well accepted, like the theory of evolution, the theory of gravity, of a lot of theories.
Yeah.
A theory is something commonly accepted that makes consensus. And something which is yet to prove, we call it a hypothesis. And this whole mix-up comes from the usage of theory in our everyday usage, because we use theory and hypothesis interchangeably, while in science they have well-defined meanings.
Okay, that makes sense. And what about the electric universe? Ever heard this theory?
Never heard of it.
Ah, okay. Well, I won't talk
hypothesis
about
then.
Huh?
Never heard this hypothesis. Then.
Hypothesis, yeah. The electric universe, it's all magnetic. I don't know anything about that. I've just read about it. I don't know a thing about it. What was another one I was going to ask you about? Yeah, so how does the gravity work?
Oh, well, the same answer as before. If I exactly knew how, I'd go to Stockholm and know. The understanding we have is massive objects distort space-time, and everything tends to go in a straight line. So then common representation we have is you take a sheet, for example, you put like a bowling ball for the sun and the ping pong ball for the Earth, and you click it, and then it goes around this whole distortion.
Mm-hmm. Yeah.
In a nutshell, that's like how I would explain it. But massive things attract each other.
Yeah. But the Earth is negatively charged, or it has a charge, doesn't it? There's the do planets themselves? Oh God, I've definitely read this, and I'm going to butcher it. But
it does have a magnetic field, but an electrical charge, honestly, I don't know.
Okay.
There are electric currents going everywhere.
Yeah.
I mean, storms are basically just huge electric discharges.
Yeah.
But I don't know if we have an overall charge of the Earth. That's something that's very interesting.
I'm gonna do a quick check.
Hey, can you please send me a message about this? I need to find this out.
Okay, does the Earth? I'll type this in there. So, what do you reckon?
Honestly, I mean, it cannot be exactly zero. They're out to be because we have a magnetic field, so we should have an electric field.
Yeah, there's definitely an electric field. Here's me arguing with an astrophysicist. I'm not arguing, I'm just bringing it up. For those who are listening who might think that I'm...
It does. A net negative electric charge on its surface. Okay, 0 also. But how much?
-5 to the 10 to the 5th power coulombs. Okay. And the atmosphere above it has an opposite positive charge of about the same.
Okay, so positively.
So a negative charge is negatively charged
on the surface. The surface, yeah.
Yeah.
So, including its atmosphere, a charge.
But the ground itself is negatively charged relative to the surrounding air. Yeah. Okay. This global charge distribution drives phenomena such as lightning, the fair weather electric field, and the operation of atmospheric electricity monitors. There we go. That's why I like to go barefoot.
Okay, so apparently you have 4 stars, roughly 77 coulombs per solar mass. And that's very cool.
Yeah. I think that's what the electric universe theory is based on, is the planets being, whether it's magnetic fields, and I mean, what the hell am I even talking about? I don't know.
But so apparently from the fact that the surface of the Earth has a negative charge and the atmosphere a positive charge, so the net charge of the Earth is roughly enough.
Is neutral.
Neutral. Yeah. Wow, that's so cool. I learned something.
Yay!
Yay. No, but that's the whole point. I love learning something every day. That makes life much more interesting.
It does. Oh, good. Well, I'm glad you learned something on this one. And I mean, it's usually me doing that.
But that's the whole point of sharing, of these conversations, and of sharing stuff with people. The whole point of conversation is for everyone to grow up, and that's the best. Mm-hmm. That's like why we also love taking pictures outside and communicate astronomy, because we're quite lucky. Astronomy is very easy to communicate because it's so beautiful. We just need to take people where you see the sky and say, hey, this is what it is. And yeah, I've been doing this for years. I got my first telescope at 10, built the first one at 12, but then I quickly got into astrophotography because it's an excellent medium to share it. Like this. It's from 10 years ago, but you can still have the idea of, hey, that's what an eclipse looks like.
So there's basically starting on the left, and as it progresses towards the right. It's the earlier, the first photo is the red one, and then or is it coming in to shift from right to left as I'm looking at it?
And also, like, there is the shifts from the camera. So, in this one, it started with this one, and the moon was going inside the shadow. Here you can see the shadow of the Earth.
Yeah. And explain to us what's going on and why it turns red.
It turns red for the same reason as, for example, when you have a sunset, you might see the sun go red because it gets light gets scattered in the Earth's atmosphere. and a bit of it is absorbed as well. And so for the same reason that sky is blue and that it goes as red when the sun sets, well, when the moon goes in the shadow of the Earth, so when there's a moon eclipse, the only light that reaches the moon is the one that went through the Earth's atmosphere, which is acting as a lens. And so you have mostly the red, which is not only more refracted, but also most of the rest of the colors are just do not go through.
Mm.
But some fun fact is if you take a spectra of the moon during an eclipse, you'll be able to infer the Earth atmosphere composition.
Mm-hmm. Yeah.
So it's pretty cool.
That is pretty cool. The other thing about the moon, which gets me, is that the reason we have this perfect, when we have a solar eclipse, when the moon passes in front of the sun during the day and everything goes dark, and it's because of the position of the moon and the size of the moon being perfect.
Ish.
Almost perfect.
Quite close, yeah.
Yeah. And that's an interesting one. Because we have a moon, we have tides, we have seasons, we have the Earth wobble, and it's and apparently because we have a moon, if you don't have a moon, the planet is basically unlivable.
It helped, but it might be livable. It just like the moon helped to stabilize the Earth's rotation. And for the reason we have seasons is not exactly because we have the moon, but we have the moon for the same reasons we have seasons. Is the main theory we have about the moon formation is a huge impact, like very early in the Earth's formation, like a Mars-sized object that impacted somewhere. And that inclines the rotational axis of the Earth by 23 degrees, hence the seasons. And all the matter that was ejected in space after this event first made a ring around the Earth.
Yeah.
And then this ring became the moon. But the moon is thought to have helped life on Earth to just stabilize its rotation and give the tides. But it's not necessary for life.
Okay. And
but it's also cool to look at.
Yeah. It's meant to be hollow, isn't it?
Not that I know of. It's basically the same composition as the Earth.
Because they have the I don't know, seismographs or whatever on the moon, and when they landed on the moon, the moon rang like a bell. Bang,
yeah. You know. But it's also like very dusty.
Yeah. And the scientists at NASA thought this is very odd. Why is it ringing like a bell? Like it's just been hit by a bell from the seismographs. And so they put they deliberately crash landed one of the boosters, from one of the whichever project it was, on the moon, and it rang for like 3 hours when they did that.
Okay.
You can check that one out as well. That's an interesting one.
It is.
Yeah.
But from its size and mass, we can infer its composition as well.
I know.
And then the samples and should not be hollow.
I know. I'm not saying it.
No one knows this. But it's very interesting.
What's his name? It's a very prominent guy who, he's in the space industry. It's not Elon Musk or anyone like that, but he's well known in that industry, and he's almost convinced that it's hollow. I mean, again, what do I know? Well, I'll tell you what, if you can pull up those pictures again. Oh, sorry, go ahead.
Sure. But that's something that's interesting about science is if we can provide the data to prove it.
Yeah.
Then
go
for it.
Yeah.
That's the whole thing is science is a way of thinking more than a body of knowledge.
Mm-hmm.
Like you have the methods you need. If you claim something, you need to have the data to back it proof.
Yeah.
And
extraordinary claims need extraordinary evidence.
But that's the thing that I think one of the things I think is very cool with this is if you have a hypothesis, no matter how elegant, if the data doesn't fit it, that means it's wrong.
Yeah.
And the science is just the best approximation we have to life. So if he claims this and has the data to back it up, it might be interesting.
Well, I'll have to remember his name, the guy's name. While you're pulling out. These are the images taken last night by our friend Melody Sky. What we're looking at.
So melodies are here.
Here we go. And that is, if you're not watching on YouTube, I'll take some photos. In fact, I'll post them photographs when she's done them for you because they're amazing. Of the blood moon lunar eclipse rising over the mountains in Verbier, Switzerland, with a slightly blue sky behind it and a little bit of speckles of stars. But that was what I did not see last night. Because it was quite early. The moon rose quite early last night.
Yes. From here, it was at 2046, and near the lake, we were supposed to have it rise at 2016.
Yeah.
Because of the mist, we only saw it roughly at the same time.
Sucks.
It's part of the game.
Part of the game.
We don't make the weather.
Yeah. So, where can people find you? Follow your research.
For my research.
Or your research
on Instagram, you can find me on Rodrigues.space. And for my research, I'm on Archive. I mean, research gets posted depending on the journals, usually in astronomy and astrophysics. But it's whenever I have something, I usually have a story about it. But my Instagram account is mostly for science communication and photography. For example, with Melody, we're also doing some events to be able to share this passion we have about astronomy and astrophotography in particular, to help people see the sky, talk about it, and also to learn how to take pictures, because a lot of photographers are very used to take daylight pictures, and once the sun is out, so are the cameras.
Mm-hmm.
So by going outside and taking pictures of the sky, we can communicate it better. And honestly, the shots are the second most interesting thing about going
fantastic.
outside and take the pictures of this. It's just an excellent side product of doing astrophotography is you get to visit amazing places, and just being at night in the mountains. Sure, you're taking good pictures of the Milky Way, but you have to be there in the first place, and you experience it, and that's so relaxing.
And yeah, and I'm so we didn't talk about it mainly because you've got some news coming out about it, but you were going to do astronomy/photography workshops up in the mountain at certain times, once a month or whatever it's going to be. And we were going to talk a little bit about that, but we got tracked on other very interesting stuff. But once you got, because I know all about the project, because I was hanging out with Melody the other day, and we'll just do this. We'll do when you've got everything set up, then we'll go and talk about it. Might even go up and do it up there. We'll do a podcast up there.
Oh yes, please. Yes, please, and just
the telescopes
together.
Yeah.
So usually I'll bring my telescope, and we'll bring our cameras, and we'll
I'm all
sky and try to shoot it. So if you have a camera, you have a tripod, the most important thing to bring is warm clothes.
Yeah, especially this time of year.
Oh, all year. Like that's the thing. Like in the winter, people expect cold, but in the summer, for example, in August, we had nights with negative temperatures, and people come like just having a hoodie, and you're like, oh boy, you're gonna be freezing.
Yeah, you're gonna freeze. All right. Well, I'm all in for that. I'm a big supporter of the project. I was hearing all about it on Saturday, and I think I want to get. I'm not involved, but I want to push it as much as I can to get people. I think it's going to be very successful. And there's a big appetite, I think, for this stuff.
Yeah,
nowadays.
And I really think like people are getting more and more curious about the night sky. Also, because like in Switzerland, as I told you, the first exoplanet was discovered by a Swiss team in 1995, but they got a Nobel Prize in 2019, and we're very lucky and very privileged in this country as well, because in our education system, we kind of learn a bit about astronomy, the basics, but we do. Like I was, last week, I was in a school and just talking about astronomy to children, because their science teacher was like, hey, let's have an astronomer come to the class. But the fact that we're giving children this opportunity, I think it's awesome.
Yeah.
I wish I had this when I was a child as well.
I'll get you into my kids' school.
Honestly, yes.
Yeah, get you up for a session.
Yeah, and the thing is, everyone wants to look at the sky. So with the light pollution we have, we need to take people out. And show them where there's less light pollution. And on a second step, what we really want to do is, as you said, trying to get lights off lower to make sky more accessible to everyone, because it's part of our humanity's cultural heritage. And here in the Alps, we have the opportunity to still have one of the slightly preserved skies. And if we can manage to bring the sky back, we'll bring more people in, because people want to see the sky, and the place is beautiful. We have everything for this.
Yeah, amen. I'm 100% behind you. I think it's really important. Well, Jose, thanks very much.
You're welcome.
That was a lot of fun.
If I made those other from yesterday as well, it's you really see the reds there. And
yeah,
I'm so looking forward for the rest of Melody's pictures.
Yeah, well, I'll post them. I'll share them when she sends them to me. But Mr. Kindness _pod on Instagram, Mr. Kindness on Mr. Kindness at Mr. Kindness on X, and at Mr. Kindness on YouTube and Facebook and all that kind of stuff. So thanks very much for listening, guys. And we're going to get Jose back soon once he's got this project that we're going to talk about, and we'll tell you all about it and how you can get involved.
Thank you very much for having me. And
no, man, absolutely.
Thank you for the nice time.
Yeah. No, it's always a pleasure. Always a pleasure. Take care, bud.
Take care.
Bye-bye.
Bye.
And we're done.